my dear students, how are you all? I hope you all are doing good. So very warm welcome to my channel. Today we are going to start with the chapter number 4 of grade 10, Carbon and its compounds, as your NCERT textbook says. Yes, I have skipped. By this chapter we are going to learn how does the bonding takes place, how does the reactions takes place between different elements, and the compound which is formed. You can learn the naming of those compounds. From memorizing the name, you can form the name by yourself by learning this chapter. Alright, so we will start this chapter, Carbon and its compounds. This part 1, you are going to have an introduction about the carbon as an element. So let's see what all we are going to learn in this chapter first. So as the name suggests, first we are going to have a quick introduction to carbon. What is carbon? Then we are going to see certain allotropes of carbon. Before that, we are going to see various features or characteristics of carbon. And then we are going to see the covalent bonds, functional groups, followed by saturated and unsaturated hydrocarbons. And then we will learn some important organic compounds, followed by the soaps and detergents. So in this way, we can cover acid and bases and metals and non-metals both, a video on it. So let's start with introducing the carbon as an element. So carbon's unique ability to form diverse and stable bond is what makes it so central to chemistry and the world around us. So why we are not talking about hydrogen, nitrogen, oxygen? Why we are giving so significance to the carbon? Because carbon is the hero element. Carbon has various properties and it is present all around our environment in various different forms, because it has the ability that makes it to bond with certain elements and form a certain compound. Its ability to form an almost endless variety of compounds is something no other element can beat. So it can form with the combination of different elements, it can form compounds which are present all around us. So first we are going to see what are the various heroic characteristics of this carbon element. So carbon can form strong bonds, right? So that is why it can form the strong bonds. That is why we can say that it has the strong bonding properties, right? And then we will see in certain sectors, in the organic chemistry, in the inorganic or organic chemistry, physical chemistry, or in the material chemistry, everywhere carbon is present. In organic chemistry, the alcohols, acids, polymers, every plastic material is considered as a polymer. So in all these chemistry, we can find carbon every here and there. Like in inorganic chemistry, we have allotropes. Allotropes means minerals like diamond, graphite, or certain fullerenes are formed by the carbon. Then we will talk about the environmental chemistry. So there is a carbon cycle we all are aware of. And then there comes a material chemistry. So all the medicines, all the electronics, all the nanotechnology is filled with carbon compounds. We are going to study one by one. Now first we will study carbon as an element. We all know what is element. Element is a pure substance formed by an atom. Okay. Simply we can say that element is a pure substance which is formed by an atom. Then carbon is also considered as an element. As we all know, all the elements are written in the periodic table. So carbon is a non-metal element which is in a solid state at room temperature, and it can be found in group 4 of the periodic table. Then first property of carbon. We are going to study about the first property of carbon. हम ऐसा क्यों कह रहे हैं कि कार्बन बहुत इजीली बॉन्ड बना लेता है सभी एलिमेंट से? क्योंकि कार्बन की एक बहुत ही हीरोइक प्रॉपर्टी है विच मेक्स इट डिफरेंट फ्रॉम द अदर, दैट कार्बन इज अ टेट्रावेलेंट 4. Now 4 are the unpaired electrons of the carbon. How does it happens? We will see. So as you can see on the screen, there is a list of elements in the periodic table. Right? So there are 1 to 20 elements written on it. So you can see this is the atomic number of an element. and this is the name of an element, and this is the symbol of an element, right? So you can see in the number 6, sixth atomic number is the carbon, and you already know that from the carbon or atomic number of the carbon we can know its electronic configuration. By knowing the electronic configuration, we can simply make the structure of atom, and we can say that in the K energy level we are going to put 2 electrons, and in the L energy level shell we are going to put 4. 1, 2, 3, 4. So can we say that 4 is the valency of carbon, and that is tetravalent, means the valency of carbon is 4 because its atomic number is 6, right? And so the electronic configuration is 2 and 4, and we got the valency of carbon, which is 4. So 4 are the unpaired electrons present in the carbon, right? So that is why it makes the carbon known as tetravalent, means 4 valency with the other atoms, okay, of the other element. This allows it to form a vast array of molecular structures, or you can say vast shapes of molecular structures, including complex chains, rings, and even networks like a diamond. It can also bond with other carbon atoms to form long chains, which are the backbone of organic molecules. So first major property of carbon is that it is tetravalent. Now talking about the bonds, which type of bonds it is saying? Carbon can form covalent bond. As we already know that in the carbon, in the equations and reactions chapter, we have already learned that there are certain reactions where the elements form bonds, and then in the resultant form they form a compound by reacting and by forming or breaking the bonds. We have already learned in chemical reactions. So if you remember, I have told you that there are ionic bonds, covalent bonds, all these bonds are formed or break. So carbon has a property that it is known for covalent bond. Now what does it mean that carbon forms a covalent bond? Let us see. So by the property of covalent bond, we means that if there are two elements and their unpaired electrons are present, and they need 2 electrons to fulfill their electronic configuration and to make itself stable, 2 elements share their unpaired electrons, okay? And when they share their unpaired electrons, in order to make themselves stable, it means they are forming covalent bond with each other. Now this covalent bonds can be single bond, double bond, or triple bond. Now carbon has the heroic property that it is a tetravalent and can form various covalent bonds with the other atoms. And that is why carbon is so significant in chemistry. That is why we do not talk about nitrogen or hydrogen much, because carbon is the one which can combine by forming the covalent bonds with certain atoms and then form various hydrocarbons, right? So let us see more about the covalent bonds now. As you can see in the picture, covalent bond, there are 2 atoms, atom number A and atom number B. So we can see there are, in the valence shell, we can say how many electrons are there? 1, 2, 3, 4, 5, 6, 7. These are the total electrons present in atom A. And atom B also have the 7 electrons. Now they need 1 electron to make themselves stable. So what they will do? They will share the electrons together like this. So in this way, by sharing the available valence electron, they can make the covalent bond, and by forming the covalent bond, they make themselves stabilized. So covalent bonds is the formation between the 2 atoms where the 2 atoms share their valence electrons to make themselves stabilized. So carbon has its stronger property. That is why they make the covalent bonds more and more and then get attached with the other atoms to form the compounds. So in this way, we can say that carbon forms the covalent bonds. So as we have learned, the major property of carbon is that it is a tetravalent. Now we are going to see how does the carbon forms bonds or the covalent bonds with the other elements. First, we are going to see certain examples of certain elements. As I've already told you that carbon can form the single covalent bonds. For example, when it forms the bonds with hydrogen, oxygen, nitrogen, and many other elements are there from where the carbon can form the bond which can be single, double or triple. For example, in methane, methane means CH4 where the carbon is 1 and the atoms of hydrogen are 4. So carbon shares the electrons with each of the hydrogen atom. As you can see on the screen, we are going to draw these bonds. First, we are going to see what are the examples. Now, if we talk about the double bonds or the double covalent bond formed by the carbon, we can see carbon dioxide as an example, or ethene where 2 carbon atoms are present and 4 atoms of hydrogen are present. You can see in the formation of carbon dioxide, carbon is forming double bond with both of the oxygen in the carbon dioxide. And here you can see in the C2H4 also carbon is being or forming the covalent bonds by forming the double covalent bonds. In this way we can say that carbon forms a double bonds. Now for the triple bond we can see there is an example of acetylene or carbon monoxide. Okay, carbon monoxide is the example. These are organic compounds we are going to learn later on where you are easily going to name the organic compound. So don't worry about it. Now we are going to learn some easy examples to see how does the carbon forms the covalent bonds with the other atoms. Okay. So this property in which carbon is forming different covalent bonds says that carbon as an element is so versatile in forming the bonding, right? It can form the bond with wide range of atoms. It can be hydrogen, oxygen, halogens, metals, non-metals, and makes the integral components of organic chemistry. It can also form certain multiple bonds, single, double, triple bonds, allowing to create variety of molecular shapes and functional groups. So here we have learned the two property of the carbon, that is carbon is tetravalent. Number 2, it forms the bonds known as covalent bonds and covalent bonds in single, double, triple form. So it means carbon is versatile in forming the bonds. It is very flexible in forming bonds with the other atoms. That is why it is very much known in the organic chemistry, inorganic, physical and environmental chemistry. Now we are going to see certain examples or draw certain examples where we are going to see how does the covalent bonds are formed by the carbons. So as you can see on the screen, there is one example where carbon is going to form the covalent bond. So there is a number 1 example which is of methane, in which carbon has 1 atom and hydrogen has 4 atoms. So we are going to see how does the carbon is going to form the covalent bond. So in your NCERT, there are 2 types of diagram you can see. One is electron dot diagram and the other one is structural formula. First we will see the electron dot diagram and then we will come to structural formula. Okay, so most major form we are going to see in structural formula only, but this is your, you can say, the raw diagrams. From this electron diagram you are going to learn the structural formula. So to know the electron dot diagram, we need to know the valency of each element, and for knowing the valency of each element you just need to learn almost or at least 20 elements you need to learn up to calcium. Okay, so as you can see, there is CH4, means carbon is going to form the covalent bond with hydrogen. So you already know that carbon has the atomic number which is 6, right? And hydrogen has the atomic number which is 1. It means it comes in the topmost list, right? In the top number. So we will form an electron dot structure like this. First we will form an electron dot structure of a carbon. As you can see, this is a structure of atom. Now in the K shell we put 2 electrons. In the valence shell we have put 4 electrons. We put 4 electrons. Now in hydrogen we already know that there is only 1 electron present. So we simply put 1 electron in its outermost shell. Now for the covalent bonds, we are going to see this is the hydrogen one and this is of carbon. So when we will place them together, so you can see the hydrogen, each of the hydrogen need how many valence electrons to stabilize? At least 2, right? Because you already know that K shell must have 2 electrons to stabilize any element. And carbon needs how much in its outermost shell? So there are 1, 2, 3, 4, 5, 6. So it needs 8 at least, right? So now we will see that this carbon is going to get attached with the hydrogen. Now this from here in the outer valence electrons, which we already know that 1, 2, 3, 4 are there. So a hydrogen get attached with these electrons, and now this electron is going to be get shared with the each one of it. Carbon also share and hydrogen will also share. Then they will form the covalent bond. And since they are sharing only single electron from each of them, so they will form single bond. Okay, carbon is giving one, hydrogen is giving one, and that is why they form single bond. You can see this is the structural formula like this. You can see there is no double bond, single bonds are there. So carbon is sharing one, hydrogen is sharing one. So in this way they get stabilized and form the covalent bond. So now we are going to see the next example, that is covalent bond of carbon forming with the oxygen. Means they are going to form carbon dioxide. As you can see, this is the carbon which have 4 valence electrons in its outermost shell, and this is the oxygen which has how many? 6 electrons, because we already know that atomic number of oxygen is 8. So what will be the configuration? 2 and 6. Here 2 and 4 is the valence electron and 6 is the valence electron of oxygen. So now what they will do, you already know that oxygen needs at least 2 electrons to share at least 2 electrons so that it gets stabilized. So we already know that in carbon dioxide there are 2 elements of oxygen are there. So we will put carbon in the middle, and these are the oxygen. So now as you can see that oxygen needs 2 electrons. That is why they form double bond. You can see here double bonds are formed. So carbon can form double covalent bonds as well. So how we are going to draw the electron dot structure of chloroform? We are going to see, since the chlorine is there, 3 chlorines are there and they need one electron to get stabilized. So what we'll do, we will put carbon here, and we already know that there is one single H is also there. So we will put like this first, because our carbon is a tetravalent. So for 1 there is hydrogen, right? All right. Now here in this we will put one chlorine. Chlorine needs to have 7. All right. So 1 is there, 2, 3, 4, 5 and 6 we will put. So like this it will bond. And then from this one there is again chlorine is there. 1 is there, 2, 3, 4, 5, 6. So again this way chlorine will form or bond with the carbon. And likewise here also chlorine is there. 1 is there, 2, 3, 4, 5 and 6. So in this way the chlorine will bond with the carbon. Alright. So we can say that in this single bonds are there. Right. Single bonds are formed. So till now we have learned the various characteristics of carbon, in which we have learned that the carbon is tetravalent and they can form single, double, triple covalent bond. Now the second most heroic property of carbon is that it is catenation. Catenation means carbon can form bonds with the carbon atom itself. Okay, carbon bonds, and then they can form various chains, long chains, rings or cyclic groups, okay, of hydrocarbons. So as you can see on the board, you can see on the screen there are certain carbons which get combined with the bonds, covalent bonds, and then they can show catenation. So by this, when the carbon-carbon chain is formed, there are certain hydrocarbons are formed, or with the strong covalent bonds they get connected and they can form stable molecular structure, as you can see on the screen. By this structure we can form various functional groups, hydrocarbon, unsaturated, saturated hydrocarbons, which we are going to learn in part 2. But what we are going to learn through this catenation property, that the carbon can form the allotropy. Allotropy means certain minerals like diamond, graphite. So by combining with carbon itself, carbon can form allotropy or show allotropy. So by showing the allotropy means it can form allotropes like diamond. Okay, so diamond is formed by the carbon-carbon chain. Okay, And then we already know that diamond is being used in the jewelry, and it is known for its sparky nature. The other compound or the other allotrope which is formed by the carbon-carbon bonding is graphite, which we normally see in our pencils, lead, or certain graphite as having the soft property, so it can be used as a lubricator as well, and it can conduct electricity. Now there is one more, graphene, which is a modern type of carbon compound, and it is quite new from graphite and diamond, and it is being used in mechanical, electrical, and various field it has been used. And now the research also said that it can be used in various sports wear as well, gloves as well. So this is the carbon-carbon bond which forms the graphene allotrope known as graphene. And apart from this, we already know that carbon is also there at carbon fibers, which we use, which you mold up and with the resin, and you make it use in certain bicycles, aeroplanes, and wind turbines. Apart from this, carbon is also present in living bodies like you and me. So about 20% of carbon as an element is present inside us. Similarly, like hydrogen, oxygen, carbon is also there inside our body. So this is the part 1 of chapter carbon and its compound, and we already covered certain big topics, and from now on the chapter is going to be easy, where we and also interesting, because we are going to learn certain saturated, unsaturated hydrocarbons, naming of compounds we are going to learn, certain functional groups we are going to learn in the part 2 section. So stay tuned and keep on revising and keep on learning. I'll meet you in the next part of this chapter. Bye bye.